Hi everyone, we're going to graph this piecewise defined function here and test for continuity at x equals 2. So we're going to do this part first and then graph and see why it's continuous or not continuous. Here's our function and here's our definition of continuity. It must meet these three conditions. So we want to see if it's continuous at x equals 2. So I'm going to check the first condition. Does f of c, this is c is your 2. Does it exist? So basically you do f of 2, and where we can put 2 into this one because it can equal 2, x can equal 2. So it's going to be 2 times 2 plus 1 equals 5. So condition 1 holds, so that's good. We do have a f of c. Now condition 2 means we're going to check the limit, see if we have a limit. That is, does the left-hand side of the c, the limit of that equal the right-hand side? And this is what that means. That means when I take the limit as x approaches 2 from the left of my f of x, that should equal the limit as my x approaches 2 from the right. So what that means is from the left, that means all numbers smaller than 2. So we're going to plug in 2 into this equation. So this would be 2 plus 1, and that gives you 3. Now, from the right, that means all numbers bigger than our 2 here. Plug that in, you get 2 times 2 plus 1, and that equals 5. This should be f of x there. Now, for the limit to exist, these two should equal, and they don't. 3 does not equal 5. Therefore, it fails condition 2, so this function is not continuous. So let's graph it and see what's going on. So basically, we always start with the 2, because that's what we have here, and we see what's going on around the 2. So I put my 2 there. And from the left, I'm going to go ahead and plug my 2 in here. So you get 2 plus 1 is 3. It can't equal it. You still plug it in. So that's going to be open. All right. And then my y-intercept there is 1. I know it's a line, but we're graphing everything from the left. All right. Now from the right, I'm going to go ahead and plug my 2 in. This is all numbers bigger than 2 or equal. If I plug in 2, I get a 5. We already did that, but it can equal it. All right, and then let's plug in another one. Let's plug in 3. If I plug in 3, that's going to be 7. So you go up to here. And you know, since it's a line, that it's going to be straight like that. So there's your graph, and this is why the function's not continuous, because we have this jump here. So we're going along. You're putting your pin on here. You're going along, but then when you get to after 2, you jump up to here. Does that make sense? So there's that issue there. So this is called a jump discontinuity. All right, and that's it. Thank you. Have a nice day. Bye-bye.